Today we're going to talk about oil analysis for industrial gear drives. Now, for the purposes of fluid analysis, we want to discuss and talk about the different types of lubrication modes when we talk about gear systems. And in our world, we want to differentiate between splash lubricated systems and pressure lubricated systems. And we'll talk a little bit about what that means in a second. In all cases with gear systems, what are we doing? Well, it's used for power transmission. Widely used in industrial applications and in a variety of different heavy-duty areas where you're trying to transfer energy or step it up or step it down. Common in power plants, common in industrial facilities. In pretty much all cases, you're going to be working with geared systems. They can be different types of hardened gears, nitrided, carburized gears. And what happens is that during the power transmission, there's always going to be some amount of wear being produced because there are sliding and rolling wear contacts when you have gear teeth meshing together. Key properties of gear lubricants that are chosen to operate for these types of applications. The gear oils are chosen and developed very specifically for the application or the type of gear system that it is going to lubricate. And you want to consider viscosity, film strength. That's the most important physical property of gear system or gear system lubricants. But also lubricants are chosen and additized for wear control. So usually there can be an anti-wear or an AW or an EP, extreme pressure additive applied. And they're also chosen and additized for oxidation resistance and corrosion control. Usually there's a rust and antioxidant RNO type of additive employed. In all cases, why do we monitor gear systems? Well, oil analysis is an excellent tool for determining abnormal wear. Remember, we said that there's always going to be wear. We get concerned when there is abnormal wear. Abnormal wear is caused when you have poor or incorrect lubricant. That could be because the viscosity is wrong oil, or it's degraded. You can have a misalignment issue. The most common way for gears to get misaligned is if the bearing starts to lose its tolerances and you start to have a little bit of chatter or play with the gears, with the bearings, that will cause chatter and slippage with the gear systems. You can have contamination getting into the oil, water or processed fluids, or debris ingress, sand and dirt contamination. Those are all going to cause abnormal wear. You can also have excessive loading, where the gear system is working, but you have an excessive load being applied to it or a variable load. That's common in industrial systems, and that can cause excess wear. The results of all this excess wear, you lead to slippage, grinding, jamming of the gear systems, tooth break off. Overall, you lose the ability to transmit power. Now back to the splash and pressure lubrication concepts. Why do we care about that? Well, in typical type of gear systems or gear boxes, a most common system to splash lubricated is usually used for lower speed gearboxes, and that's where the oil is in a bath lubrication system and the oil is drawn up by the gear systems and it is squeezed through the gear teeth during the normal operation. For higher speed gear applications, you need to have pressure lubricated systems, and that's where the oil is sprayed directly onto the gear systems. So with those two types of application, how do we monitor that from a perspective of oil analysis? Well, in all cases, we want to look at viscosity. It's the most important physical property of the lubricant, so you definitely want to require that for both splash and pressure systems. Ferrous density is an excellent screening tool for the large abnormal ferrous wear that can occur when you have abnormal wear being produced. You want to check for water contamination. It's the most common liquid contaminant getting into the system. Oxidation and acid number is critical to determine if the lubrication oil is degraded beyond its normal useful life. Elemental spectroscopy is excellent for looking at the additive elements that are present, as well as the very fine wear that's being produced, ferrous wear, as well as the non-ferrous wear that can be common in a lot of gear systems, especially with bearing supports, as well as in sacrificial gear systems such as worm gears. Particle count We say it's optional for splash lubrication systems. They're usually high viscosity above an ISO 320. So ferrous density is a great screening tool. But if you have pressure lubricated systems, the viscosity is a much lower, and it's usually filtered by way of, because it's needed for filtration for the pump. So therefore we recommend particle count on a pressure lubricated system. And finally, ferrous particle count, optional on splash, recommended for pressure systems, and wear debris analysis, or WDA, should be an optional requirement when you identify a problem occurring and you want to do root cause diagnostics. So what are the solutions we propose for on-site analysis of industrial gear drives? There's three major systems that you can consider. They're all in the mini lab category. The Mini Lab 33 is a great screening package, and it's excellent for splash drives because it's got viscosity, ferrous density, water, oxidation, and tan included. 53 is perfect for pressurized systems because it's got the particle count and the ferrous particle count included. And then the 153 system includes the elemental spectroscopy, and it's ideal for all types of industrial systems.